The WS12000 has a user interface screen that is a touch screen that provides the ability to monitor how well the sorting is doing, as well as make adjustments as you're running to improve the sort of accepts and rejects. It is a dual spectrum sorter, which means that it is looking at color, which is displayed on the screen. And here is a walnut that has some black material on it as well as good. We'll place it in the image area, and it sees it in the color. You can also look at it in infrared, and in infrared it easily shows the difference between the good shell and, as I'm turning this, the black husk that is stuck to it, or even a stain from the husk. The adjustments for the user is sliders that can be moved back and forth, and they're very explanatory. For the near infrared, you would want to eject less of the good product. You would press this and it moves this number that direction. Or if you want to eject more bad, if you are not ejecting some of the material you would like, you would press this and it moves more that direction. It also does the same with the color of a good nut, indicated by this color scheme, as well as the ability to get off color. And again, you would move to ejecting less good product or ejecting more bad product. The last slider is a shape algorithm that looks for shapes other than that of a good walnut, and it identifies that, and that has an adjustability to it. There is a button on the user interface screen called Training. When this button is pushed, the operator is instructed to place a number of good walnuts on the vibrator tray and then in turn run them through the system. The software uses these images to identify what the various parameters in infrared, color, shape is for good products. It then uses this algorithm to identify what an average size of walnut is in the sample. Based upon that average size, what we call the trained average, the size is set based upon that. You can eject small if it is less than what you have identified as the percent of the trained average. In this case, we're ejecting everything that is half the size of an average walnut, whereas you can also eject anything that is greater than a certain percent of the trained average, and in this case we're ejecting what is greater than 150%, or half again as big as a normal walnut. Another feature of the WS12000 walnut sorter is the ability to take one particular object that got ejected and it should not have, or it was missed, and do some analysis on that one particular object in order to help set up the parameters that accept or eject. And that would be to come to this button which says Object Analysis, and if I push that button, it opens up some buttons and screens, and I can take this object that has some husk material, partially good, partially bad, and simply drop it through the image area as shown, and on my screen I see that image that was captured with some data overlaid, and I see the mask that it saw, an infrared level, and a color level, and these numbers tell me based upon the legend down here. The first number is the percent bad infrared, the next is the percent bad color, the next is the shape value, and the next is the percent of the trained average size. So it has to do with the size of the nut. The first number, 40, tells me that it sees 40% of a bad infrared level. The next number is 10, which tells me that it sees 10% of a bad color. And then 17 is the shape, and 139 is this particular nut is 139% of the trained value that we got when we did training. On the slider screens, we now have an LED next to each of the levels, and a lit up LED in green tells me that it would eject that nut based upon that particular parameter. It passed the other parameters. In the same way, sticks can be identified. As I put this stick in the image area, you can see that it has picked up the stick, and the red dot says that it's going to blow that stick. And the third number, the 5758, is the shape number, and it is an elongation number that we're using a number on the shape line of 25, and anything higher than that number gets ejected, and that's why we have a 54 being ejected. Whereas if I place just a size of a almond, then its number is 15, which is below the 25, and so it identifies the shape and the elongation in that way. Sometimes a good walnut and what needs to be ejected, as in this case of a bark or stick, is the same color and infrared signature as a good product. We're able to use size in this case because this piece of bark is bigger than and the average size, and I will demonstrate by dropping this good product through the image area, and it captures it, and it sees the third number. As we remember down here, the last number is the percent of the trained average size, so that number is 126. So this is a little bigger than the average that we had placed in, but it is below our 150% that we're ejecting for it being too large. But if we take this bark and drop him through the image area, it is captured, and we see that it's 236 times as big as the average, much bigger, and we see the red dot that it would have ejected that based upon that. And in this case, we see the green light that shows that it was ejected because of large. We also see in this case that we have identified a 37 in the third number, which is the shape, and our threshold is 25, so it was bigger than the 25. It's longer, obviously, and we see the green LED that shows that it also ejected based upon that parameter.